Carissa explains it all. What are you explaining today? Capacitors?
Capacitors.
We talked about this last week that I wanted you to explain capacitors because of condenser microphones.
Yes.
Or you were calling them capacitor microphones.
Well, I said they can be called capacitor microphones.
You're very quiet, so you have to either get that microphone closer to you or talk louder.
Is this better?
Yeah, that's better.
Okay.
Not really.
I was trying to keep it out of my face. But,
Well,
you know.
pick it up. Physically up. There, up.
All right. Now it's right in my line of sight.
That's good.
Okay.
You're getting better signal.
Better signal. Okay. That's always good. Okay. So capacitors. What is a capacitor? A capacitor is a two-terminal electrical component that stores electrical energy in an electric field. Simple. Very simple.
So you pipe electricity into it and it holds on to it.
Yep.
Okay.
So the effect of a capacitor is called capacitance.
How does it hold the electricity?
Well, I'm getting to that.
Okay.
Physical structure. Most capacitors consist of two electrical conductors in the form of metallic surfaces separated by a dielectric medium.
Define dielectric.
A dielectric is a non-conducting.
Got it.
So it can be made from glass, ceramic, plastic film, paper, mica, oxide layers, mylar, Teflon, or even air. Basically, the type of the dielectric determines the use of the capacitor.
And what it sounds like.
Sure. But, you know, depending on the use of the capacitor,
Sure.
it may not necessarily be a sound application.
Fair enough.
So how does a capacitor work? The plate that connects to the negative terminal of the battery accepts electrons that the battery is producing. And the plate that connects to the positive terminal of the battery loses electrons to the battery. So once charged, the capacitor has the same voltage as the battery. So
What happens when it's charged?
current stops flowing, unless there are other circuit elements. So if you put, like, for example, a light bulb
Sure.
on the left side over here between the battery and the capacitor,
Yes.
while the
On the negative side.
Yeah, on the negative side. While the capacitor is charging, the light bulb will be lit. Once the capacitor is fully charged, the light bulb will go out.
And then depending on the capacity of the capacitor, that's how long it would take for it to fill up.
Yeah.
Yep. Cool.
So that's a capacitor in a nutshell.
It's a way to create an off switch that happens automatically over a period of time.
Right.
Cool.
And uses for capacitors. So there's energy storage. There's digital memory. Like some of the earliest computers actually used capacitors as a binary memory.
They still do. I can't tell if you're visible on screen. Keep going.
I can't tell either. Pulsed power in weapons use capacitors.
Lean back a little.
Can't lean back a little. There's nowhere to lean.
You're in shadow is the problem.
Well, that's you and the light. Power conditioning, power factor correction, signal coupling and decoupling, high-pass and low-pass filters, and signal processing.
It's not true. A low-pass filter is a resistor.
Resistors and capacitors are usually used in sequence, in series.
Yeah, okay. So next week you're going to walk us through the schematic of a high-pass and a low-pass filter.
Okay.
And you'll find that low-pass filters are resistors. Resistance creates a low-pass filter. Okay, signal. Okay, what's next?
So, that's it.
Cool. So